Hi, in this video and the future video, we are going to see how statistics plays an important role in the data science lifecycle. Statistics has wide range of application across domain and industry. Specifically in the data science lifecycle, statistics is used in data pre-processing, data analysis, identifying important relationship among data, feature engineering, insight lifecycle, where it can be used for generating patterns and insights out of the data. And post insight cycle, if it's a machine learning model, after the model has been deployed, statistics is used in analyzing model and data drift. So statistics plays an important role across the entire data science lifecycle. This video is not to teach you statistics, but to introduce statistical thinking in the data science process. I might have simplified some of the techniques that I used over here, but as we get into more complex videos in the future, I will elaborate those. So, said that, let's get started with the coding part of it, right? So, what I'm going to do here is I'm first going to apply the statistical technique in a very simple process, like imputing missing values. Now, whenever we talk about missing values, there are multiple ways you can impute a missing value. You can do a mean, you can do a median, but let's go through a step and see like how the data distribution is and what is the right way of imputing data, and is there any correlation that I can use within the data to impute my target value. And that's what we are going to do over here. Let's get started. I'll go into the details of the data set, and then as we go, you will get clarity better on what we are trying to achieve. So for this video, I am importing pandas, NumPy, and for visualizing the data, I'm going to use Seaborn and Matplotlib. So let me run this first cell. I'm going to use a telecom churn data set. This is like IBM telecom churn data set, but what I have done is I have created a simplified version of the data set because there are too many features in it. I just taken like selected features and done some engineering. So for this video, you will get an idea on how in real world imputation is done. At the same time, I didn't want to have too many features. I wanted to simplify the data set. That's the background. So let me run this and let me show you how the data set looks like. So before going there, what I did is I have just copied this data set that I have loaded into another data set, so that if I want to go back to the master copy, I can go back to it. And I am printing the first few lines of the data set. So there are multiple columns over here. There's a customer ID, which is a unique identifier for the customer. The senior citizen column is telling whether this particular customer is a senior citizen or not. It is a telecom churn data set, and the idea is to predict whether a customer will churn or not. And the churn column that you are seeing is the target column. No means the customer has not churned. Yes means the customer has churned. This is based on historical data. So senior citizen is a variable. The tenure is how long the customer has been with the telecom company. So 1 month, or it's in months, so it's 1 month, 34 months, 45 months. So it's telling the months the customer has been the months the customer has been in the telecom company. The service count is how much services does the customer have from the telecom company. The customer might have a phone line, an internet line, a streaming TV line. There are multiple lines he may have. So how much services does he have? Whether he's on a month-on-month contract or a yearly contract is the contract column. Whether he has a paperless billing or not, that is the other column. The monthly charges is basically how much is his monthly charges that he's paying to the telecom company, and total charges is during the tenure of his particular lifetime being a customer of the telecom company, how much total charges he have paid. And as I said, churn is going to be is going to churn or not, right? So these are the different columns that are available. And let me quickly do an info of the data set. So you can see basically most senior citizen, tenure, service count are all integer, whereas senior citizen is a categorical value because it's 0 or 1, but because it's not coded as string, it is considered as integer, but it has a string column. And the monthly charges and total charges is a float column. Now, as I said, I'm going to discuss about imputing missing value. So let's go and check it out which column has missing value. Now, if you see like all the columns are fine, the total charges column over here has 28 missing value. Now I can randomly go and drop the data because it's only 28, but I want to see, think if you have a data set where 20% missing value is there, is there a better way to impute the data, right? I don't want to lose the row because if you let me run the next line, so that you see like how much rows and columns that we have over here. Now, if you see over here, I have like 7,000 rows and 9 columns. So for 28 columns with null does not impact much. I can drop it, but think like if I have like 700 rows that has null, I want to see how I can impute it, right? So that's I'm going to show how to impute it, not rather drop it over here. Now there are different features of it. The details will show you like this is showing you like which has missing value, the total charges as missing value, how many how many unique values are there in the row. There are multiple aspects that I am printing. So if you really see, I'm printing the shape, that is the rows, columns. I am doing a feature list, I am doing a missing value and the unique value. That's what I'm printing over here. But let's get started with the data set. Now that we know, our aim of this particular video is to impute missing values on the total charges column. So the first thing I want to do is I want to see all the rows that has missing value. So basically what I'm doing over here is I'm doing the churn df dot isna wherever there's a isna value, and I'm telling the access as 1. That is the get all the rows over here. Any access equal to 1, just display it, and I'm assigning it to the churn data frame. So basically it's going to give all the index and it's going to show me all the rows where it's null. And if you see over here, all these columns, the total charges has not a number value, right? So everything is na. And let me quickly scroll down, and if I see over here, there are 28 values is what we saw, and most of this is churn put no. So like all the null values is pertaining to churn, where the churn is no, right? And there is a monthly charge column, and typically like if you see monthly charges as correlation with total charges, because like finally your monthly charges over time accumulates to total charges, right? And it also has correlation with tenure, right? Just a quick glance, it has correlation with tenure, because based on the tenure your total charges can be imputed. But I'm going to take a step by step approach. I'm going to first do if there is a univariate column that can possibly predict a total charges, and then we will see like multivariate as well, right? And if you see the tenure column, right, you have multiple tenures of customer where the null is there, and I can see lot of zero over here. So it is not a single output that is going to solve it, right? Whenever there's a zero, there is high possibility the total charges can be null, because the customer has not even paid a single month of monthly charge as of today, right? So we need to see like how we can impute the zero value, and then we have to see how other values can be imputed. Now in the next step, let me specifically go to the zero value, right? So yeah, all this tenure are zero over here. So what I'm doing is I'm printing where the churn df of tenure is equal to 0, and then you can see basically all the tenure, the monthly charges are there, but the total charges are null. So I can either like just copy the monthly charges to total charges, or I can just put 0. It depends on the modeling type. Some of the models that you are going to use, if it's a XGBoost model or any kind of gradient boosting model, it supports null values, then I can just impute it to a very high value. In some cases where the model is very much very much adaptive to outliers, right? I cannot substitute a high value, so I need to substitute a value which is in line with it. So let's see how what we are going to do with it. But there are two categories over here: one with tenure equal to 0, and other is tenure greater than 0. So we have to handle both of this in a different way, right? So let me quickly describe the column. What I'm doing is I'm doing churn df of total charges dot describe. I'm just seeing descriptive statistics of that particular column. And if you see over here, the maximum value is 8684, whereas the mean is only 2284, and the 50%, that is the median, is 1398. So you can see like a lot of variation in the data as well. So if we impute with mean, irrespective of the tenure and monthly column, I'm going to get 2284 as null value imputation. If I impute with median, then everything I'm going to get 1390, which is not ideal, because what we saw is there are customer with multiple tenures as well, right? So let now, since our target in this case churn is no for all the customer, I'm going to just focus on the category no. So what I'm doing is I'm doing a churn df where churn equal to no, and then I'm going to get describe to see the descriptive statistics of that particular total charges where the churn is only for no customers. And even if you see here again, like the median is 1686 and the mean is 2557. So again, like you can see lot of variation because the max value is 8672, right? So what we will do is we'll just do a box plot so that we get a better understanding of the data. So here what I'm doing is I'm just doing an SNS, which is a seaborne package box plot, and I'm giving total charges as my x-axis, and I'm just splitting it by churn. So whether I'll get two, one for churn S and no, my focus is going to be churn no. Churn S has a lot of outliers if you see over here, which is more than the maximum range. But churn no, there's no outliers, but still it does not look to be a normal distribution, right? If you see over here, basically the quantile one is somewhere close to, let me go to the previous screen as well. So quantile one is 25% is somewhere close to 578. The median is somewhere close to 1686, right? But the maximum value is 8672, and even the mean is 2557, somewhere over in this range, right? So basically if I put a mean on median, then I maybe I'm not imputing it correctly. Let's see, like what is the best way of imputing it, right? So this is basically, let me quickly also generate a histogram of the total charges value to see how the distribution of data is. If you see over here, the total charges distribution is basically not Gaussian. It's completely right skewed, and you can see it. So now either I can use total charges directly, but some models are pretty immune to the distribution. But in this case, what I can do is I can just apply a power function or an exponential function and try to see whether it somewhat close to normal distribution. So here what I am doing is I am applying a square root function, right, which is the power of 2, power of 1 by 2, that is zero point 0.5. I'm applying a square root function, and somewhat like the distribution is better now. I've taken the same data over here, right? So basically, in this case, we are not altering the data. We are just changing how the data is represented. The data still has the same distribution when you compare each other, right? I'm just altering the representation of the data. So when I take an exponential function or an power function, basically the distribution is getting better. But for this illustration, I will go into details in the next video sometime with a different problem altogether, like how to apply this function so to make it normal. But for now, I'm just going to take the distribution as it is in this video, right? So I'm going to take total charges as it is, and the distribution is rightly skewed. Yes, so I'm going to do with that. So now coming to how we are going to solve it is, first we are going to check the monthly charges column. Can I impute total charges with the monthly charge column? So that's my first thing I'm going to do. And if you see over here, what I am done is I'm using an LM plot, which is nothing but a convenient way of convenient interface to fit a regression model across subset of data. So I will talk about the subset of data. This is just going to fit a regression line. So let me run this, and you can see over here. Basically, what I am doing is I am taking my x-axis as monthly charges and y-axis as total charges, and I have given my u as churn. So basically, the light blue that you are seeing is churn S, and the dark blue you are seeing is churn no. And there are two lines that are fitted over here, which you are not able to see properly. I will change the color and I will show it as we go into the next. So basically, this is how the data looks like, and the data does not fit properly even if you take individual category. Let's go to the next video, next basically statement, and see how it looks like. Because here what I am doing is I am splitting the churn S and no. So in this case, again, I'm taking x-axis as monthly charges, y as total charges, and here I am adding a column churn. So basically, LM plot can provide you subsetting, and that's what I'm doing. When I say column churn, it's going to split the graph into yes and no. So now I have a yes, basically a scatter plot of yes value and a scatter plot of no value. And in our case, we are more focused on no value. And if you see no value, basically there's a line cutting over here. Again, it's kind of blended with the original color. So what I'm going to do is I'm going to change the color to red. So I'm using the same command, but I'm telling my line color is red over here so that I'm able to see that particular value better. So now you see I'm able to see the value better. Now while this looks like an there is a relationship, but there is no strong relationship. That's what I can see, because the data is spread across. Even if I fit a line, the standard error is going to be pretty high in this case, right? But let's go and see the correlation and see how these both variables are correlated. So I'm going to run an correlation between total charges and monthly charges. That's what I'm doing over here. Now, if you see over here, between the total charges and monthly charges, the correlation is around 0.65. It is towards positive correlation, and there's some correlation. We cannot discount that. There's a pretty good correlation as well. 65% correlation is there. Now, correlation is a number between 0 to 1, sorry, minus 1 to 1. My More towards negative one shows a negative correlation. More towards the positive one shows a positive correlation. Somewhere between 0 and close to 0 shows there's no correlation. It depends on what kind of threshold we want to put. But in our case, I'm going to more focus on churn equal to no. So I'm going to check here the same correlation, but I'm only checking only for where churn equal to no, because I want to specifically impute the data with churn equal to no records, right? And here, if you see, the correlation is even better. When I do a churn equal to no and try to get the correlation, there is a 75.75 correlation, which is even better than the entire data set, right? So now what I'm going to do is I'm going to focus on only churn equal to no records, right? And I'm going to create a new data set, which is churn no df, which contains which contains all the churn equal to no record, and where the total charges is not is na. The reason I am excluding total charges also is, first I'm going to use it to build a model, and then I'm going to go back to the null records and then impute with it, right? So that's why I'm creating a data frame purely with the churn record equal to no, and where there is no null over there, no empty records or no missing value over there. So I have 5146 records, right? Let me quickly see the churn node df, whether there's a null. There is no null. As I said, I have excluded the null. Now the first thing that I'm going to do is, since there is an pretty good 0.75 relationship, there's a positive correlation over here, I'm going to fit a simple linear regression model. So I'm going to use the stats linear regression package. I'm importing from SciPy import stats. I'm going to use an stats linear regression package. And what it does, it calculates a linear least square regression for two measurements. So the first measurement that I'm giving is a monthly charge, which is my independent variable, and the second is the total charge, which is my dependent variable, right? That is the target I'm trying to predict, because I want to impute total charges, which has null value, right? So let me run this, and it gives output basically it gives slope, intercept, r value, and p value as output. Let me print it and let me talk about it. So the slope is the slope of the regression line, right? The fit of the regression line. The intercept is basically your intercept. So if you go above this one, this is the slope, and the intercept is basically where it cut across in the y-axis, right? Now the next is your r value. The r value is the correlation coefficient. In this case, we saw it's 0.75. Basically, the p value is your hypothesis test over here, right? It is a two-sided p value test that statistic linear regression run, and the p value is also used to determine the importance of the variable, and which is 0, which is like basically the variable is pretty significant over here. You have the standard error, which talks about the total error, that is like the error of this estimated gradient. The line is cutting across all the variables, but that not everything fits the line. There are points which are outside the line. So these are the total error of the non-fitted value. And then you have r square value. Basically, the r square value is kind of an proportion of the variance in the dependent variable that is predictable in the independent variable, right? So our dependent variable is monthly charges. What is the variance of this particular model that is used to predict the independent variable from the dependent variable? So in this case, what I see, the r square, it's able to show around 57% variance, right? That's what I can enter. But the standard error is also pretty high in this case, right? Now, if I can go and run this, you can see this is how the line is fitted, and this is the equation. Basically, it's a typical line equation this intercept, and this is your coefficient, and the x value is what you're going to supply as input. So it's basically fitting this particular line. The lot of points that are outside the line. That's why the standard error is pretty high, and you can see basically the standard error is pretty high. So now I want to see whether there is a variable better than that, right? Something that can cover more variance and then less standard error. So next, what I'm going to do is I'm going to purely use tenure to see I can predict the total charges. And similar to what I did for monthly charges, I'm going to do an LM plot where the tenure is the x-axis, and basically it's a linear regression plot that I'm doing. And then y is my total charges, and then I am going to just visualize the output over here. And if you see over here, this is how the fit looks like. Let me split the s and no variable in the next one. So what I'm doing is I'm giving the column as churn. So now if you see, still the line is fit, but still you can see like the lot of data points lies outside the line. So still it's going to produce an output with an pretty high error. But before going there, let's check, let's check the correlation and see how the correlation is. The correlation is 82, which is better than what we saw in the monthly charges. And let us do the correlation only for the no variable. Now the correlation only for the no variable is also pretty good. From 75 it has come to 79, right? So let us try to use only this variable and try to predict the slope and intercept, and also R squared and standard error. So I just run this again, the same stats package, linear regression, and I am going to show the output. Now, if you see over here, earlier it was around 57% of the variance that was predicted. Now it's 62%, but at the same time, the standard error has increased. If you go to the previous one over here, the standard error is only 68, but now the standard error is close to 80. Basically, there's more error, but the R square, the variance has improved. So still not a great model that we have. Right, let me quickly draw the line, and you can see the slope and intercept printed on the top. So this is again, tenure is also not helping us. Now let's go to the problem that we have, right? So basically your total charges is a combination of tenure and also monthly charges, right? It's a combination of both of that. So can I use both of this variable and then predict my total charges? I also have the actual total charges, so I'm going to show you how our final model has performed, right? So what I'm doing is I'm creating a new column in the churn node df. And basically here what I'm doing is I am multiplying the tenure with monthly charges. So even though tenure is basically more like a interval data, but as I said, I'm going to keep it simple rather than doing a bucketing and everything for tenure. I'm going to simply just multiply my tenure and monthly charges and assign it to a tenure charge variable, right? And then I'm just printing an output over here. You can see the tenure is a combination of total charges and your tenure, right? So that's how the output is. Now I'm going to check the correlation. I'm going to check where only no. I'm going to check the total charges, where the tenure charges, the column that we created now, and see the correlation. And if you see the correlation, it's almost close to 1. That means there's a perfect fit over here, right? The correlation is basically almost positive and almost towards the higher end. Now let us quickly plot the data and see how it looks like. Now if you see over here the output has basically, earlier if you see, the graph was pretty broad. The points were completely outside of the fitted line, but here in this case, if I fit a slope over here, then you can see like most of the points will be covered and the standard error will be comparatively lesser, right? So let's go and see the output of, again, the stats.linear regression model, where I'm using tenure charges as my input and total charges is what I'm trying to predict, right? So let me run this and let me run the output, what it is. So now if you see, the R square value is almost like 0.99, which is close to the higher end, and your standard error is substantially reduced, right? In the real world, you may want to also use some data to test it outside of it to see how it is performs with an unseen data. But just to quickly show like how the data is fitted and everything, just to keep it simple, how statistical thinking can be applied to imputing missing values. That's the purpose of this video. So I'm seeing a pretty good fit over here, right? So let me go and again, like draw a regression plot with the see, there's a regression plot over here with the regression line, and you can see almost like the line is close to near fit, and this is the output. Basically, the coefficient is almost 1, and there is a intercept which is around 0.435. Right now, I'm going to go and impute the data for the actual column, and I'm going to see how it is performing against the actual value. As I said, I have also the actual value. So in for that, I'm creating a function over here. So the function basically takes the tenure and monthly charges, because we are multiplying tenure and monthly charge. And if the tenure is 0, right, we already know if the tenure is 0, basically the output is non, which is a right value, right? In this case, I'm just moving monthly charge to with the output, right? So basically, rather I imputing 0, I'm just moving monthly charge. I can go and impute 0 also in this case, right? If the tenure is not 0, then I am creating the variable that I created, tenure into monthly charge, and then I am just using the intercept plus total charge into slope. So whatever variable comes in, it's going to predict the total charge value for this, right? That's what the line equation is there on the top, a linear regression equation. That's what I have created a function. And then what I'm doing is I am creating a new column, in this case called total charge new, which is the column with an imputed value, right? And then I'm telling like the churn df dot apply. I'm using an apply function. I have created a lambda function internally, and I'm telling if the total charges is na, right, if the total charge is not na, then just print the total charges as it is. So wherever total charges is there, just keep total charges. If it is na, then I'm calling this fill na function. This is the function I created on the top. If you see here, the fill na function, and I'm passing the tenure and monthly charges, and then assigning it to a new column called total charges new. So let me run this, and let me run the out how it looks like. So if you see over here, wherever the, now again I am printing wherever there is na, right? The total charges is still na, but the total charges new column I have already imputed and populated, right? So let's see like how it is performing against the actual data, because for some of the value where tenure is greater than 0, I have the actual value in the data set, right? So for that, I am going to quickly load another data set called churn data underscore actual, which is again there in my GitHub repo. You can download it, and I'm going to quickly merge this data set, the actual data set, with the churn df that we populated on top, and then I'm going to just print the output over here, same wherever null record is there. So now if you see the last two columns over here, I'm sorry, just 1 minute. The the last two columns over here, uh, let me go down and let me move the bar towards the end. Yeah, let me just a minute, let me quickly reduce my resolution size, because yeah. So last columns over here. Now if you see over here, the total charge actual is the actual value, and the total charge new is the new value, right? So here what I am doing is, if you see the actual value is 48116 over here. See, for the variable that is missing, that means the tenure is 0, and for tenure is 0, we are just imputed directly, right? Because I don't have in historical also that value. So wherever that tenure is not 0, if the 4811, what our model predicted is 4788, pretty close. 320, 298, 649, 638. So all the values that the model has predicted is pretty close over here. Now we can also try to go and add service count to it, because what will happen if you see with the tenure, the customer might have multiple services over the tenure. Maybe does the service count make sense? As we have more data, when we have more variables, maybe we will be able to get better outcome. But we cannot exactly approximate. We are just approximating it with a closer value, something similar to what with the actual, rather than just imputing a median or mean. If I had done a median or mean for all of this value, the output would have been 1300 or 2200, whatever we saw on the top, right? So basically, the idea of this video is just to show like how rather than just blindly imputing an mean or median or using a knn imputer, seeing a relationship between multiple variables and see how we can impute the target value. So this was a simple video, but as we go into the future, we'll go with complex techniques to complex data set and see how statistics can be applied, so that we get a better relationship and a better outcome to the target value. Thank you.